Hello guys, welcome back to TechDose, and in this video we will be discussing about count the number of good subarrays, which is from Leetcode number 2537. Let's now look at the problem statement. In this problem, given an integer array nums and an integer k, return the number of good subarrays of nums. A subarray ARR is good if there are at least k pairs of indices i, j such that I is less than j and array at I equals array at j. That means we are trying to find equal pairs. A subarray is a contiguous non-empty sequence of elements within an array. Now if you consider this nums, then if the given value k equals to 10, then we want to find the number of good subarrays. A good subarray is a subarray in which the number of equal pairs are at least k. That means it can be greater than equals to k. So there is only one such subarray, which is this entire array, where the first item will be forming 4 pairs. You see, the first item will be forming 4 pairs. The second item will be forming 3 unique pairs. Similarly, the third item will be forming 2 pairs and the last item only 1 pair. So if you add up 4 plus 3 plus 2 plus 1, then that will come out to be 10, which is greater than equals to your given value k, right? So this is a good subarray, and there is only one good subarray in this case, right? Similarly, if you look at the second example, with k equals to 2, then there are 4 good subarrays. The first good subarray can be 3, 1, 4, 3, 2, 2. That means this subarray can be good, right? Here the pair 3, 3 is equal and 2, 2 is equal. So there are 2 equal pairs. This means this subarray is valid. And if this subarray is valid, then you know that even if you include more items on the right side, it will always be valid from the same start point. So that is why starting from 3, you have 2 valid subarrays, 3 to 2 and 3 to the last item 4, because you can have more pairs than k. It is just asking about at least k pairs, right? Even in the subarray from 1 to 4, there will be 2 equal pairs, 4, 4 and 2, 2. And if you take from 4 to 4, then again 4, 4 and 2, 2. Therefore, 4 good subarrays are present, and so the answer is 4. So I think the problem statement is very clear. In this case, the constraint says that the nums length will be maximum 10 to the power of 5. So you cannot write an n square algorithm, because n square will take 10 to the power 10 computations, and I have to write less than 10 to the power 8, right? So an n log n algorithm or something better will be required here. The nums I and the k values are 10 to the power 9 maximum. That means it will fit in the integer range. Now let's look at some observation in order to solve this problem. Our approach here will be, if let's say from 0 to 5 we have a valid subarray. A valid subarray is one where the equal pairs are actually greater than equals to the given k value. 0 to 5 is valid because 5, 5 is a valid pair and 2, 2 is a valid pair. So the count of valid pairs are at least k. So this is a valid subarray. And if this subarray is valid starting at 0 and ending at 5, then I can take starting at 0, ending at 6, and this will definitely be valid, because increasing the number of items will never decrease the number of valid, the equal pairs, right? Even if you include the 7th item along with the 6th item, you are not going to go below 2, right? You can always increase or remain the same. So if 0 to 5 is valid, then 0 to all the indices to the right of 5 will always be valid. And that is why if I know 0 to 5 is valid, then I can take the size of the entire array, where n is equals to 8 in this case, and whatever is the index here, which is 5, so I can take n minus I and say that there are 8 minus 5, that is 3 valid subarrays which are starting at 0. That will always be true, isn't it? Now if 0 to 5 is good, that means valid, then I found that there are 3 good subarrays from 0 to 5, 0 to 6, 0 to 7. But maybe starting at 1 and ending at 5 would also be valid. Who knows, right? So we have to try that out. If you try out from 1 to 5, you will see that yes, this is also valid, because again 5, 5 and 2, 2 are present. And if 1 to 5 is valid, then 1 to 6, 1 to 7, everything will be valid. So again I can add 3 to the count and this will become 6, and likewise we will continue. So all the subarrays starting from 0 and ending at index greater than equals to 5 will always be valid in this scenario, because as I said, the count of equal pairs cannot decrease if you are increasing the number of items by moving to the right. It will always be greater than equals to k. That is the reasoning. And I said already that maybe starting at an index greater than 0 and ending at the same index 5 would also be valid. So we need to try that out by excluding this 0 and try to just take 1 to 5. So try for increasing left indices unless the sub array has count of equal pairs less than k. That means if I have tried from 1 to 5 and found that it is valid, then again I will increase my start pointer, or you can say the left pointer, and I will try for 2 to 5. Is this valid? No, this is not valid because there are no k number of equal pairs. There is only one equal pair, 2 comma 2. This left side 5 is lost. So if you have to track this sub array, then you can take left and right pointer. That is obvious, right? And once you actually come to a conclusion that starting from 2 and ending at 5 there is nothing valid, then we will be moving this right pointer to the right hand side to make a valid subarray starting at 2. Because if you cannot make a valid subarray starting from 2 and ending at till the last index, then you can never make a valid subarray starting from 3 and ending at the last index. That is never possible, right? And that is why the 2 pointer sliding window approach works here. Okay, so we can just extend this and check with 6. So at 6 we are including 5. So you see 5 comma 5 is also equal pair. So there are k number of equal pairs at least. So 2 comma 6 becomes valid. So add 2 count, 2 to 6 and 2 to 7. So likewise we will be solving. So I think you have got the idea of why we are going to apply 2 pointer and sliding window. Now in this case, how to count equal pairs. Now let's say that my one count is 4. That means 1 is occurring 4 times and 2 is occurring 3 times. So if you have to count the total number of equal pairs in this entire array, then this one will be forming 3 equal pairs. This one at index 2 will be forming 2 equal pairs, and the one at index 3 will be forming exactly 1 equal pair. These are all the unique pairs, right, where I is less than j. So if you add it up, it will be 3 plus 2 plus 1. When the frequency of 1 was equals to 4, then I got total number of equal pairs due to just 1 as 3 plus 2 plus 1, which you can say that 3 times 4 by 2, which is n into n plus 1 by 2, right? Simply. So that will be equals to 6. Okay. So just by knowing the frequency, you can easily calculate how many equal pairs it can form. So if 1 has 4 frequency, then you can take n into n minus 1 by 2 and simply get the number of equal pairs. And the same goes for 2. 2 will be forming an equal pair with index at 4 and at index at 6, and this fourth one will form only one pair with 6. So total 3 unique pairs are present, right? And you can easily calculate by 3 into 2 by 2. Okay. So the total number of equal pairs in this array due to 1 and 2 will be equals to 9. Here I am not considering k value because I just wanted to show you how to count equal pairs. Okay, once you have understood this, let's see the equal pair counting method. Well, I know that for tracking the equal pairs, counting it, I will require the frequency of each of the unique elements, and for that I can take a map. A simple hash map will do, where I will be taking in the key the unique element and in the value the frequency of that unique element, and I can just process moving from left to right. I can keep track of the frequency simply, right? So again, I'm not taking the k value here because my purpose is just to show how the count will be adjusted. So let's say that I have taken a left and right pointer, and when I see a 1, I will be just including the frequency. Now if I ask you about, will this 1 form a valid pair? Well, something with just one frequency cannot form a valid pair because you need at least 2 items. So this will never form a valid pair. If you look at 2 and the frequency will increase by 1, again since this is less than 2, it will never form a valid pair. If you look at this one, then the frequency will increase by 1, right? So at this point, since 1 has 2 frequencies, so the number of valid pairs will increase because the frequency is greater than equals to 2. That is the time when valid pairs will be included. So if you include a 1 on the right hand side, then the number of ones on the left hand side will decide how many valid pairs will increase. So since this is the second one which is coming, because the frequency of 1 is 2, that means only a single one was present on the left hand side. So the number of valid pairs increment will always be frequency of whichever element you are looking at, in this case 1 minus 1. Okay, because I have already incremented the frequency. So the equal pairs will increase by 1. Okay. Now when you look at this one, the frequency is increasing to 3. Now since you are adding another one and the frequency became 3, that means there are two ones to the left hand side already, and how many pairs will they form with this newly added one? They will form 2 pairs. That is calculated by the frequency of 1 minus 1, which is 2. So the equal pair count will increase. And similarly, if you add 2, then the frequency of this 2 will increase to 2. That means there are 2 2's. So how many 2's are to the left of the newly added 2? 2 minus 1. That means 1 2 is present on the left hand side. So the number of valid pairs it forms will exactly be 2 minus 1, which is 1. So add 1 and it will be 4. And you can continue to do the process. If you see a 1, again the frequency becomes 4. That means 3 ones are present on the left hand side. So the number of pair increment will be 4 minus 1, which is 3. So 3 will be added. So this is how I can keep counting the number of equal pairs while moving the right pointer to the right hand side. Now let me show you how to decrease the equal pair when you decide to move the left pointer to the right hand side. So if you decide to do that and you remove this index 0, then the frequency of this item will decrease by 1 and this became 3. Now since this became 3, this means you lost a 1 from the left hand side, and if you lose this 1, then how many pairings are you losing? You will be losing these many pairings, right? Frequency of 1 minus 1. Okay, but since I have already decremented the frequency, then I should subtract 4 minus 1, that means 3. If you first decrement it, then you have to subtract 3, and if you do not decrement it initially, then you have to subtract 4 minus 1. So 3 frequency have to be subtracted and this becomes 4. Okay. Similarly, if you try to lose this 2 and move the left pointer to the right hand side, frequency of 2 becomes 1, and if that happens, then that means a 2 has been lost from the left hand side. So the frequency will decrease by 1, whatever is the new frequency. So this becomes 3. Again, if it so happened that there was another 2 here and here you had a 1, then if you lose another 2, then the frequency of 2 will become 0. And in that case, you do not need to decrease any equal pair count because the frequency was already 1. That means there was just a single element, so there was no pair. Okay, so if there was no pair, then how can you decrement anything? After decrementing, if the frequency is greater than equals to 1, then only you can lose pair. But after decrementing, if the frequency is 0, that means the previous frequency was 1, so there was no valid pair. So what we will decrement? So I think you got the idea of how to do equal pair counting. Once you have understood this, let's do a dry run using the 2-pointer hashmap approach. So in this case, I will be taking the good subarrays equals to 0 and equal pairs equals to 0 with k value equals to 2. That means a subarray will be a good subarray if it has at least 2 equal pairs. So let's see. I will be taking this right pointer and I'll keep moving the right pointer to the right hand side until I reach out of bound, or actually I have k pairs, k equal pairs. Okay, so I will be including this one, and since this frequency is 1, therefore no equal pair increment is going to happen. Now for this 5, I will increment the frequency, and since this is 1, no equal pair is actually incremented, right? For this 2, since again the frequency is 1, so no equal pair increment is going to happen. For this 5, I will increment the frequency and move to the right hand side. Now since this frequency is 2, that means to the left of 5 there was another 5. So the equal pair count will increase by 2 minus 1, which is 1. Okay. Now I will be checking if the equal pair count is greater than equals to k. No, it is not, right? It is not equal. So I will be processing the next item 3. So for 3 the frequency is 1. So no good pair is going to get added. For this 2, the frequency is going to be 2 and we will move to the next item. Now since this frequency has become 2, that means there was another 2 to the left hand side, and so the frequency of equal pairs, that means count of equal pairs, will increase by 2 minus 1, which is 1. And now since the equal pair count has become greater than equals to k, therefore my loop will break. My right pointer is at 6, not at 5. According to my code, it will be at 6. Now starting at this left index 0, how many good subarrays are present? So I know that from 0 to 5 we have a good subarray, but the right pointer is pointing to 6. So in order to include the count of good subarrays, you can say that it will be n minus r plus 1, right? So that will be equals to 8 minus 6 plus 1, which will be 3. So 3 subarray count can be included and this will become 3, right? Now these all subarrays are 0 to 5, 0 to 6 and 0 to 7. Now since I have included them all, let's try to move this left pointer to the right hand side and try to exclude this one and see that if I can have a valid subarray from 1 to 5 as well. So if you do that, the frequency of 1 is going to be 0. That means if the frequency is 0, the previous frequency must have been 1. So it is not decrementing the equal pair. Okay. Therefore, 1 to 5 is also valid. And if it is valid, again add 3 count, which is n minus r plus 1. So if you add 3 count, it will become 6. And simply again move this left pointer to the right hand side. If you do that, then this index 1 will be lost. That means I have to decrement its frequency. And since the frequency has become 1, it is greater than 0, right? That means we are losing one equal pair. Okay. And if we are doing that, then I have to reduce the equal pair count. And since the equal pair count has become less than k, that means 2 to 5 is not valid. So I'll continue to move this right pointer to the right hand side. So include this 5 and the frequency becomes 2. Since it becomes 2, that means another 5 was to the left hand side. So the equal pair count will increase by 1. Okay. After including, definitely I will be moving the right pointer to the right. So it will stop at 7. Now how many subarrays are present from 2 to 6 and 2 to 7? How to count that out? N minus r plus 1, which is 8 minus 7 plus 1. There are 2 subarrays, 2 to 6 and 2 to 7. So add 2 and this becomes 8. Okay. Now you try to move this left pointer to the right hand side. My right pointer is at 7. Okay. But actually our end point is 6. So now if we are losing this index 2, then you have to decrease the frequency by 1. And since the frequency is 1, we will be losing one equal pair. So this will become 1. And now 1 is less than k. So 3 to 6 is not valid. So move your right pointer to the right. Include this 6. So this will be adding a new element and you will go out of bound. Once you go out of bound in R, then you cannot move further. And we will keep moving this left pointer to the right hand side. Now you check. I mean, the equal pair count hasn't increased. So even if we move it to the right, it wouldn't matter, right? We can actually break here. If the right pointer has gone out of bound and the equal pair is less than k, then our equal pair is never going to increase. Or another strategy can be to break when the left pointer goes out of bound. Any loop condition is going to run. So I will be using a simpler one, which is left will go out of bound, then we will be stopping, right? So in this case, 8 will be the final count of good subarrays, and that is how we will be counting it. So I think this approach is extremely clear. So every element is traversed no more than 2 times. And so if there are n items, we are traversing order of n times. 2n times, which will come out to be order of n. And the space complexity can be order of n due to the hash map. So the time complexity is order of n, space complexity order of n. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the nums array and the k value. So I have defined a bunch of variables with long because the return type was long. Okay. So after that, I will be running the loop until the left pointer goes out of bounds. So this piece of code is the right pointer will keep moving to the right unless right goes out of bound or the equal pair count until it reaches the value k. It will continuously keep on moving to the right. So include an element and increase its frequency. Then check if the frequency is greater than equals to 2. If it does, then add the frequency minus 1 to the count of equal pairs as I have explained and move to the right hand side. Okay, and after you have either gone out of bound or equal pair count is equals to k, we will be checking if the equal pair count is greater than equals to k. If that happens, then everything from 0 to I plus 1, I plus 2 and so on till the last index will be valid. Okay, will be valid. whether it is 0 or not, it does not matter. It can be j from j to I plus 1 and so on. Everything will be valid, so it has to be added. And once it is valid, let's say from j to I it is valid, then the left pointer will be incremented by 1 time to check if from j plus 1 to I it is also valid. Okay, so if you do that, then the left index here will be lost, and so its frequency will be reduced. And if its frequency happens to be greater than 0, this means we are losing equal pairs. And if we are losing, then we will be reducing the equal pair count and move to the right hand side. That means the left pointer will move to the right. And finally, if the entire process is over, that means the left is actually going out of bound, then we can return the count of good subarrays. So this is the entire approach, and I hope it is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.